My name is Dhiraj, your math teacher. So we know the motto of Vista's learning. It is to provide quality education to each and every one of you. So yes, without delaying the things on special demand and high demand, we're going to start our today's session because there has been a few of the requests to start this session or to take this chapter. And yes, when I was child, I also struggled with this chapter initially, but then my teacher explained it so well that it became so much easy to me to score the full marks in this chapter. So can you guess the name of the chapter? It's triangles. I understand this chapter is a bit pathetic because what happened is earlier the concepts that were in class 8 and 9, we didn't go through them properly. And once we come to class 10, these concepts that we don't know properly help us, means pulls us back in solving questions and getting the things clear at that instant. And finally, what we do? We stop reading this or we start hating this particular chapter, but it is not the case. Today onwards, after attending this class, you're going to love the chapter. And yes, I can simply say with or by looking at the simple questions, you can directly tell what the answer is going to be. So without any delay, we are going to start the chapter. So here, how it actually started, the concept, how it actually started, it is going to start from a very important topic known as polygons. Polygons, wow, or how it is related to triangles. The first thing, what actually a polygon is. A polygon is simply a two-dimensional figure that is going to have finite number of sides. Finite means countable, uncountable and countable, finite, countable, infinite, uncountable. We are going to call it like this. So polygon is a figure, or we can simply say a closed figure that is going to have finite number of sides. So here minimum you can see 3 sides are required to make a polygon. Then 4, 5, 6, 7, 8, 9 and 10. We can move ahead of 10, but we cannot move less than 3. Okay. So a side 3 in a polygon with side 3 is termed to be as a triangle. Side 4, quadrilateral. Side 5, pentagon. Side 6, hexagon, heptagon, octagon, nonagon, decagon. If we move to 11, undecagon, 12, dodecagon, and like this the things are going to continue. So here what we can see, we have to discuss of triangles. We are going to discuss with triangles. So in triangles, what we saw right now is, it is a polygon that is going to have 3 sides, and then this polygon is a closed figure. Let's move to the next part of triangles. So a triangle is a closed shape. This closed word is actually very important. We can use the word polygon or closed shape. Both are the same thing. Closed shape with 3 angles, 3 sides and 3 vertices. Is that the case? Let's see a triangle. So that is a triangle. You can see I'm going to name it as A, B and C. A triangle is a closed shape. It is a closed one. You can see no way to move out or no way to move in inside the triangle. So that is a closed shape. Now that is going to have 3 angles. That is one angle. That is one more angle. That is one more angle. So yes, it is going to have 3 sides, 3 angles and 3 vertices. So 1 vertices, 2 vertices and 3 vertices. So yes, now I can say that it is a triangle. But you know what? Triangle is not only restricted to these many things. We can divide triangles according to the sides. We can divide triangles according to the angles of that particular triangle. So they are referred to as a types of triangles. We'll discuss this later in today's session only. So I guess till now it was very easy because we are recapping the things from the previous classes so that you don't miss out any concept. And yes, if you're enjoying it, you can like and subscribe, as well as you can go to our web application www.vlearning.in and you can rectify and you can ask your doubts. We are there to help you 24/7. Let's move to the next part, the types of triangles. That is the thing I was discussing right now. What I was discussing, it was the types of triangles. So see here, you can say the triangles can be divided by sides, the triangle that we are going to divide by sides are equilateral triangle, where all the three sides will be of equal measurement. Isosceles triangle, where the two sides will be of equal measurement and the third side will not be of the measurement of theirs. If all the three sides will be of equal measurement, we are going to call it equilateral triangle. Finally, scalene triangle. In scalene triangle, none of the sides are equal in length. They are all of different measures. So we call it scalene triangle. Now, if we are going to find, or if we are going to part the types of triangles according to the angles, so here we have three. Again, first one is the acute angle triangle, second one obtuse angle triangle, and the third one right angle triangle. So what we know about acute angle triangle, that all the three sides of the triangle is going to be less than 90 degree. Less than 90 degree. You can see here. In obtuse angle triangle, any one angle will be greater than 90 degree. Any one. All the three angles cannot be greater than 90 degree. That is the reason why in obtuse and right we use only one angle. So if any one angle in the triangle is greater than 90 degree, we call it obtuse angle triangle. And finally, in right angle triangle, again any one angle is going to be equal to 90 degree. So here equal to 90 degree, here greater than 90 degree. So these are the types of triangles how we are going to divide, by sides and by angles. I guess you are getting the things very easy. So this recap, it is going to help you get all the concepts of triangle. So let's start with the properties of a triangle, and this property is actually very important. So now onwards, whatever we are going to start, it is very important for the syllabus and the recapitulation of the things that you have demanded for. So here, first, a triangle has three sides, three vertices, and three angles. We have already seen that. Okay. Next, the angle sum property. See this blue color mark, the underlying things. Angle sum property. Angle sum property means what? The interior angle of a triangle sums up to be 180 degree. How, sir? So see here, you can see this. That is a triangle. Let us name it as A, B, and C. I have named it as A, B, and C. So that is one of the angle, that is the another angle, and that is our third angle. So if we add angle A plus angle B plus angle C, angle A plus angle B plus angle C, it is going to be 180 degree. That is called the angle sum property. When we add three angles of a triangle, interior angles actually, then it sums up to be 180 degree. Now the question is, how do I know? So there is a formula, and the formula is n minus 2 into 180 degree, where n belongs to the number of sides. N is equal to number of sides. So this number of sides that we are going to discuss, it is actually important. So we know that so here, yes, yeah, okay, fine. There were some technical issues. Happens, yeah? Okay. So in this particular triangle, what we saw, that it is going to have one. Give me a second. I guess there's some technical issues. I'll fix it right away. Yes. It's fixed. Okay. So here in this particular triangle, what we saw, that it is going to have 1, 2, and 3. Three sides. That means n is equal to 3. So n, that is 3. 3 minus 2 will be equal to 1. And 1 into 180 will be equal to 180. Like this, if we have 4 sides, 5 sides, 6 sides, and we're continuing with like this, then we can use this particular formula to find the sum of interior angle of that particular polygon. So that is the formula that you can use to find the sum of interior angles of that particular polygon or closed figure. Let's move to the next property, that is this. It is the third property. triangle inequality property. Actually, that is very important. So what this property says is, suppose if in a triangle there are three sides. Let us take a triangle. So in this particular triangle, there are three sides. Again, A, B, C, no, X, Y, Z. X, Y, and Z. So if I add XY plus YZ, I am simply adding nothing else. XY. Suppose it is 3, it is 4, and that one is 5. So what I can see, if I add 3 plus 4, it will be greater than 5. If I add 3 plus 5, it will be greater than 4. If I add 5 plus 4, it will be greater than 3. So if we add any two sides of a triangle, if we add any two sides of a triangle, it is going to be greater than the third side. So that is the property, one of the very important property to identify that it is a triangle. So let us see or imagine that is a line, and in that particular line, the sum of two sides is less than the third side. So it will form a line only, but if it is greater than, it will form like this. So it is going to be a triangle. So that is how this concept came into the mind. Now you are getting the things. Let us move to the next property, that is the last property of this. It is the side opposite to the greater angle is the longest side. That is also very important. So in this particular triangle, you can see that is the longest side. So the angle opposite to it, this particular angle, will be the greater angle, and vice versa. That means if that is the greater angle, so the side opposite to this particular angle will be the greatest side. So that is the fourth and the last property of the triangle. After that, we are going to continue with the theorems. So till then, here what you can see, whatever we have discussed. So yes, don't miss out the theorems. They are actually very important. We'll start with the concepts of Pythagoras theorem. Pythagoras theorem, you have heard it from class 8, I remember, where you used to take a right angle triangle, and what you have to do, you used to square the hypotenuse to find the other sides. So square of hypotenuse is equal to the sum of the square of base and perpendicular. So here in a right triangle, so this word actually right triangle, it is anyhow related to Pythagoras. The square of the hypotenuse equals to the sum of the square of the other two sides. So if it is a right angle triangle, so there will be sides. Let us see. That is a triangle, and I am going to tell that it is a right angle triangle. So here A, B, and C, that is a love triangle. Sorry, right angle triangle, isn't it? So here what you can see, that the side that is perpendicular to base or at 90 degree with the base is referred to as perpendicular. The base part that is attached to the ground or attached to the horizontal, we considered it as base, and the longest side in the triangle, we took it as hypotenuse. So the formula is hypotenuse square is equal to base square plus altitude square. So that is the formula what we have got. So the longest side, square of the longest side is equal to the square of sum of the other two sides. That is the thing, it is written over here. And I guess Pythagoras theorem, I need not to explain that much because you already know that. I believe it because I know your capability and I know that how good you are in studies. So don't worry. This particular things, I know you know it from the very beginning, but yes, anyhow I have revised it because I also don't want to miss out anything, and this revision will help you remember the things better. Let's start with, it's jumping, exterior angle partner. It will always jump. So before explaining this thing, what I'll do, I'll use the diagram. So this diagram, you can see we have different colors, multicolored, technicolor you can say. So that is red, that is purple, and that is green. I'm not teaching a colors, okay? So why this thing? So ABC is a triangle, and what we did is we have extended the line AC. You can see we have extended the line AC. So the exterior angle, this BCD, the exterior angle BCD will be equal to an interior angle A plus interior angle B. Now, do you know the reason why we do like this? So the reason is, see, if that is a straight line, that is angle X and that is angle Y. Let us take it like this. It is a straight line and one of the angle is x while the another angle is y. So if we add x plus y, we will get the answer as 180 degree. A straight line or straight angles are equal to 180 degree. Again, if we talk about the interior angles of a triangle, the sum of interior angles of a triangle, these three, again it is also going to be 180 degree. So what we can say? Angle A plus angle B plus angle C will be equal to 180 degree. Okay. So this is a straight angle here. You can see that is a straight angle. That is exterior of C and interior of C. So this C and this C will be cancelled out if we equate them. So what we got? The exterior angle X will be equal to angle A plus angle B. So simply if you want to remember the concept, so if any or one of the side has been extended, so the exterior angle there will be equal to, so just leave the angle that is with related to that, it will be equal to the sum of the other two sides. That is how the things we got. So exterior angle property actually is very important. But yes, this concept was there in class 9th mathematics. Let us move to the next theorem, that is similarity. We basically get confused with the word similarity and congruency. Similarity means look alike. Suppose we have some Salmon Bhai. Let us take Salmon Bhai. You guys are actually fan of Shahrukh Salman, and now you know the Valentine weeks are also going on. So let us take Salman Bhai, and he's there, and he needs to perform a stunt. Will he go by himself and perform the stunt? The answer is simply no. We'll get a duplicate of Salman Bhai to perform the stunt, isn't it? So the duplicate is known as similar. Again, similarity does not mean the biceps, the triceps, the chest, arms, it will be exactly the same. No, it can differ. Everything can differ, but the ratio or proportion should be same. That means two triangles are said to be similar when they have two corresponding angles congruent and the sides proportional. So you can see here two triangles. One is of greater in size, one is smaller in size. But if the angles that we are discussing about are in the same ratio, or if the sides are in the same ratio, then we can simply say that these two triangles are similar. So the symbol for similar is this. In physics, we use this symbol for AC current or alternating current, but in mathematics, we are going to use a symbol for similarity. So similarity will be like this, and congruency will be equal to and similar, or we use triple equal to for congruency. But for similarity, we only use the current wave, you can say. That is the thing, how it moves on. So what is the similarity? Simply it means look alike. Look alike. But sizes can differ, the ratio cannot differ, or it should be the same one. Let's move to the next part. We have similarity. So here, now we got congruency. Congruent figures. You must have heard about the congruent figures. So here two triangles are congruent if their corresponding sides are equal in length and the corresponding angles are equal in measure. Means exactly the duplicate, no changes. If there is a Thanos, the another Thanos will be there. So there are two Thanos. Everything should be same. If one Thanos is doing like this and entire half of the world is like empty, if the another Thanos also does like this, the entire world should be empty. So it should be exactly the same. No difference in angle, no difference in the length, no difference in any other thing. All of the things should be exactly the same. Then and then only we can say that the two triangles are congruent. So you can see a yellow triangle and a red triangle. Both the triangles, the length are equal, as well as the interior angles are also equal. Angles are also equal, lengths are also equal. Then we can say that these two triangles are congruent. So this congruent sign refers entire thing exactly the same. If the length of one side is 5 centimeter, So the length in this side will also be equal to 5 centimeter. It cannot be 5.1 or it cannot be 3. The ratios are same. If the ratios are same, it is similarity. If exactly equal, it is congruency. So that is the difference between similarity and congruency. So till here, if you have any doubt, you can comment, and I'm going to check your comments right now. How many of you are actually waiting and demanded for this class? I'll see the comments and then I'll reply. Give me a second. I'm just looking out for the comments. Okay. Hmm. Yes, I can see. Okay. Good morning, everyone. I can see people are wishing good morning. Yes, it's a very good morning, and yes, I was also excited to take the classes. Okay, fine. We'll start with the things. I can see 4-5 people they are waiting right now, and most of them are in our app asking questions. So don't worry. After the class, I'll reply to all your questions, and you'll get the answers. So let's start with the two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So this thing actually we have discussed right now, and that is the diagram. We have also discussed about these things. Let us move to the theorems. And this theorem is going to help you solve all your doubts and achieve a very good marks in your examination. So the theorem one is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So let us first get the diagram. You can see that is a diagram. So here what we got is triangle ABC, it is already present, and this EF that we have got, it is a line that is parallel to BC. This line is parallel to BC, and this EF is going to intersect AB at E and AC at F. It is going to intersect AB at E and AC at F. So now, if we look in this particular triangle, and this particular triangle, okay, I'll name them as BEC and CFB. If we're talking about this two particular triangle, we can say that this triangle and this triangle will have equal area because they are lying between the same parallel lines and they have the same base. So using that parallelogram theorem, we can say that yes, these two triangles are equal in area. Again, so if we are going to find the area of this, it will be area of a triangle is equal to half into base into height. Half into base into height, it is going to be the answer for area of a triangle. And this area of a triangle that is equal to half into base into height will be the answer for your maximum questions. So here I can take this as the base and that one as the height, because these two will also be parallel as the things are parallel. Same with this one also, this one as base and this one as height. So this one is height. So if we equate them, if we take the ratio, the answer will be AE, this part, divided by EB, EB will be equal to AF, AF divided by FC, FC. So we will get this particular part. So what we say, that a line drawn parallel to any one side of a triangle divides the side in equal ratio, and this is also known as BPT or basic proportionality theorem, because the sides are divided in proportion. I guess this is becoming very easy now. We'll move ahead to the next theorem, that is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Again, the BPT, but in opposite. So what we call it? Converse of BPT. We call it converse of BPT. in converse of BPT, we have a triangle A, B, and C. We have a triangle ABC. Again, this E and F, there I'll take this part as F dash. So F dash and F are actually very close. So this EF, if the ratios of AE and EB is equal to AF by FC, then what we are going to say that the line EF and BC are parallel. So that is the opposite of basic proportionality theorem. That is the reason why we are going to call it as converse of BPT. Let's move to the next theorem. It is, if in two triangles corresponding angles are equal, then the corresponding sides are in the same ratio and hence the two triangles are similar. Let us take two triangles. So here that is one of the triangle and that is another triangle. What I did, I took it and I have placed it here. So what we saw that yes, it is exactly lying on the sides and this one of the angle is actually the same. So here as the one of the angle is actually the same, what we can say here is this angle and this angle will be same, equal. Angle are equal. So what we can say is by angle similarity or property, we can say that the two triangles are similar. Similar means simply they will look alike, but the size can vary, size can differ. So here by angle concept or angle similarity concept, we can say that the two triangles are similar. Let's move to the next theorem, that is, if in two triangles, side of one triangle is proportional to the side of the another triangle, then their corresponding angles are equal and hence the two triangles are again similar. Okay. What we got is side and angle. Side and angle are two angles and one side are in the same ratio. So two angle and one side, if all of these three are in the same ratio, then we can say that the triangles are similar. So what is the property? We have used one angle, then one side, then again one angle. So angle side angle property or similarity concept, we can say that yes, the two triangles are similar. Moving to the next part, we have, if one angle of a triangle is equal to one angle of the other triangle and the side including these angles are proportional, then the two triangles are similar. Again, let us draw a triangle. So what we got, one angle and one angle, they are equal, while the side that is connecting the angles are also in the same ratio or same proportion, then these two triangles are also similar. That is the thing we have got right now. So yes, by side angle side property, we can say that these two triangles are similar. I guess now the things are getting very easy because we know the name, we know how the things are moving on. So let us start with the next theorem, that is, the ratio of areas of two similar triangles is equal to the square of ratio of corresponding sides. Actually, that is very important. I'll write it here. This part is actually very important because whatever you are going to solve, it is going to help you a lot in solving all your parts. So that is important. I'll put a star mark here so that you should not miss why I am telling this. So yes, we have two triangles. So what the part is, the areas of the two similar triangle is equal to the square of the ratio of corresponding sides. So it is actually the ratio. If I am going to name it as A, B and C, this one is X, Y, Z, then what we get here, like area of triangle ABC divided by area of triangle XYZ will be equal to square of any one side. If I am taking AC, here I will take XZ. AC square by XZ square. Or I can take XY and AB. AB square by XY square. Or I can take BC and YZ. That is equal to BC square by YZ square. So that is the thing we got. So yes, the area of the ratio of area of a square or area of a triangle is equal to square of the ratios of their side. That is a theorem. So that is actually very important. You should not miss this part. Let's move to the next part. We have, if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then the triangle on both sides of a perpendicular are similar to the whole triangle and to each other. So let us take a right angle triangle. You can see now, if I draw a perpendicular from here, so now we got two different triangles, this and this. So these two triangles, as it is perpendicular here, that part is also going to be perpendicular. This part will be perpendicular, then this part will also be perpendicular. So this triangle, the upper one and the lower one, this triangle, both of them will be similar to a right angled triangle. Exactly the same, exactly like the bigger triangle. It is going to be similar. So that is the thing we got in theorem 7. Let's move to the 8th theorem we have. In a right triangle, the square of hypotenuse is equal to the sum of the square of the other two sides. We call it Pythagoras theorem. Pythagoras theorem. We have already discussed about this theorem. Like if I have a triangle in which one of the side, that is a base, perpendicular, hypotenuse, so B, P, H, the answer will be H square will be equal to P square plus B square, and that is the Pythagoras theorem. Finally, the last theorem of our session today, and with that our classes are going to end. In our next class, we will be discussing about some of the important questions from triangles that has already came in your examination, and they are actually very important from examination point of view. But today's session will be up to this. So in a triangle, if square of one side is equal to the sum of the square of the other two sides, then the angle opposite to the first side is the right angled triangle. Again, the same thing, we can call it to be the converse of Pythagoras theorem. Converse of Pythagoras theorem. What it says that if the square of any one side is equal to sum of the square of the other two sides of a triangle, then it is a right angled triangle. So I guess this Pythagoras theorem, the right angle property, the concept, it is actually very clear to you from the very beginning. So that is the thing why I am not discussing about this at this particular moment. Rest everything I have made it clear, and I guess you guys have also understood it. So don't forget and don't miss out the next class that is going to come, because in our next class I am going to come with the questions that are actually very important from your examination point of view, as well as the question that has already came in your examination. So don't miss out the other session, and I hope you have understood the things very well. If you have understood it, you can give a like, a thumbs up, and I'll come to know that yes, my work for today is actually done. So with that, we have successfully completed our, what we can say, the chapter triangles. Let's meet in our next class. I'm really very excited to meet you all in our next class. Until then, bye-bye and all the best.